So for today's video, let's do some experiment for projectile motion. So first, let's make a projectile motion launcher. So here are the materials that needed for our projectile motion launcher. So first materials on our list is a timer, popsicle stick, disposable spoon, a protractor, a ping pong ball, tape measure, glue gun with a glue stick, and lastly is the rubber band. Caution! Please be careful in using the heat gun para di ka masakitan.
Gigi try sa gi. Away mo ti. One, two, three, go.
Yeah.
Trial given angle is equal to 80 degrees, acceleration is equal to negative 98 meter per second squared, delta x is equal to 1.10 meter. Let's proceed to solution. To find the initial velocity, we need to use the formula given. We have velocity squared is equal to initial velocity squared plus 2 times acceleration times delta x. So the value for velocity squared is equal to 0, equals initial velocity squared plus 2 times the acceleration, which is the value of negative 9.8, times the value of delta x, which is 1.10. So 0 remaining equals initial velocity squared plus 2 times 9.8 multiplied by 1.10. The answer is negative 10.78. So next step is 0 is equal to negative 0 initial velocity squared multiply 2 times negative 10.78. The answer is negative 21.56. So in order to get the initial velocity squared, we need to transpose initial velocity squared to the left side. So it will become negative velocity squared, initial velocity squared is equal to negative 21.56. So multiply both sides by negative in order for them to become positive. So it will become positive initial velocity squared equals 21.56. So in order to cancel the square, we need to square root both sides. So it will become initial velocity equals the square root of 21.56. So the final answer is initial velocity is equal to 4.64 meter per second. To find the value for initial velocity of horizontal direction, we need to use this formula. Initial velocity times cosine theta. So equals 4.64, which is the value of initial velocity, times the cosine 80. 80 is the value of the theta or the angle. So it equals 4.64 still times cosine 80, which is the answer of 0.1736. Multiply that to 4.64 times 0.1736. The answer is 0.806. Round up to the nearest hundreds. The answer is 0.81. So the final answer for initial velocity of horizontal direction is 0.81 meter per second. To find the value for initial velocity of vertical direction, we use this formula. Initial velocity multiplied by sine theta, so equals 4.64, which is the value for initial velocity, sine 80 degrees, which is the value for the angle. So 4.64 multiplied by sine 80, which is 0.98. Multiply the two of them, 4.64 times 0.98, the answer is 4.569. Round up to the nearest hundreds, the answer is 4.57. So the value for initial velocity for vertical direction is 4.57 meter per second. To find the value for delta y, we will use this formula. We have final velocity y squared is equal to initial velocity y squared plus 2 times acceleration y delta y. So the value for final velocity y squared is 0. Substitute is equal to the value of initial velocity y squared, which is 0.57 squared plus 2 multiplied by the value of acceleration, which is negative 9.8 delta y. So copy 0 is equal to 0.57 squared is equal to 20.88. 2 times negative 28, the answer is negative 19.6 delta y. Next is we will transpose negative 19.6 delta y to the left side. So it will become positive 19.6 delta y is equal to 20.88. So in order to get the value of delta y, we need to divide both sides by 19.6. So cancel 19.6 to the left side, the remaining is delta y is equal to 20.88 divided by by 19.6. So delta y is equal to 1.07 meter. To get the value for time, we will use this formula. Final velocity y is equal to initial velocity y plus acceleration y time. So the value for final velocity y is equal to 0, so substitute is equal to the value of initial velocity y, which is 4.57, plus the value of acceleration, which is negative 9.8 time, or t. So copy 0 is equal to 4.57, copy, and then negative 98 times positive, that is negative 9.8 time. We will transpose negative 9.8 time to the left side, so it will become positive 9.8t is equal to 4.57. So to get the value for t, we will divide both sides by 9.8. So cancel. So the remaining is time, or t, is equal to 4.57 divided by 9.8. So the value for time is equal to 0.466. Let's proceed to get the total. So total is equal to 2 times t, or time. So total is equal to 2 times the value for time, which is 0.466. Multiply the two of them, so we will come up the final answer of total is equal to 0.93 seconds. For the second trial, the launcher fired at 70 degrees angle and reached 0.98 meter distance from the launcher. So we're going to determine the initial velocity of the ball. So we use this formula. Final velocity squared is equal to initial velocity squared plus 2 times acceleration times delta x, which is the distance. So we're just going to substitute the value. The final velocity is 0, and 2 times negative 9.8 times 0.98 is equal to negative 19.21. And we're just going to transpose the initial velocity squared to the other side and eliminate the squared. So we're going to use the square root. And square root of 19.21 is equal to 4.38. So our initial velocity is 4.38 meter per second. Now that we have the initial velocity of the ball, we can now determine the initial velocity in the horizontal direction, which is the Vix. So we can use this formula. Vix is equal to initial velocity cosine theta. And our theta is 70 degrees. So 4.38 cosine 70 is equal to 1.5. So our initial velocity in the horizontal direction is 1.5 meter per second. Also, we have to find the initial velocity in the vertical direction, which is the VIY. So VIY is equal to initial velocity sine theta. So substitute the value, and 4.38 sine 70 is equal to 4.12 meter per second. Next unknown is the maximum height, so we're going to use this formula. V if y squared is equal to VIY squared plus 2 times acceleration of y times delta y, which is the maximum height. The value of VIY is 4.12 meter per second. Then quantity squared plus 2 times negative 9.8 meter per second squared times delta y. 4.12 squared is equal to 16.97, and 2 times negative 9.8 is equal to negative 19.6 delta y, and it turns into positive, and divide both sides by 19.6. So 16.97 divided by 19.6 is equal to 0.87. So our maximum height is 0.87 meter. In finding time, we use this formula. V if y, which is the final velocity of y, is equal to VIY, which is the initial velocity of y, plus acceleration of y times time. The value of final velocity of y is 0, and the initial velocity of y is 4.12 meter per second plus negative 9.8 meter per second squared times time. We're going to transpose the negative 9.8 time to the left side and divide both sides by 9.8. So 4.12 divided 9.8 is 0.42 seconds. So for the hang time, we're just going to multiply the time by 2. So 2 times 0.42 seconds is equal to 0.84 seconds.
For the third trial, the launcher fired at 60 degrees at an angle and 0.85 meter distance of the launcher. So, we are going to determine the initial velocity of the ball. The formula that I am going to use is the velocity squared is equals to initial velocity squared plus 2 acceleration delta x, or which is the distance. So our given in here is the acceleration, which is in 9.8 meter per second, and the delta x, which is the distance, is 0.85 meter. So our velocity squared is 0, and just copy the initial velocity squared plus 2, and our acceleration is negative 9.8 meter per second, and our distance is 0.85 meter. So negative 9.8 meter per second squared times is 0.85 times 2. So the answer is negative 16.66. So we are going to square root the negative 16.66, and the answer is 4.1 meter per second. So this is now our final answer, and this is the initial velocity. And next, we are going to find the initial velocity of horizontal direction. So the formula that we are going to use is the initial velocity of horizontal direction is equal to initial velocity cosine theta. And we have here the given is the initial velocity is 4.1 meter per second, and the angle theta is 60 degree. So the initial velocity is 4.1 cosine, and an angle theta is 60 degree. So 4.1 cosine 60 degree, and our final answer in here is 2.1 meter per second. The initial velocity of the vertical direction in the formula that we are going to use is the VAY is equals to the initial velocity sine theta. And our initial velocity is 4.1 sine, and our angle is 60 degree. So the answer is 3.6 meter per second. And now I am going to solve the maximum height, and the formula that I am going to use is the delta y is equals to the initial velocity of vertical direction squared plus 2 acceleration and y. So the initial velocity of vertical direction is 3.6 squared plus 2, and the acceleration is a negative 9.8. So 3.6 squared is 12.96, and 9.8 times 2 is negative, and the answer is a negative 19.6. So negative 12.96 divided by negative 19.6, and the final answer is 0.67 meter. So this is our maximum height. And last, we are going to solve the time. So the formula that we are going to use is t is equals to the initial velocity of vertical direction divided by the 1/2 acceleration and y. So our initial velocity of vertical direction is 3.6 meter per second, 1/2, and our acceleration is 9.8. So 3.6 over 4.9. And our final answer is 0.73 seconds, and this is our time.
So, in the three trials, we can conclude that as the angle increases, everything increases except for the initial velocity in the horizontal direction. As the angle increases, the initial velocity in the horizontal direction decreases.